Okay, now I'm going to explain subgraphs. Now let us consider a graph as shown here G. Now it has four vertices A, B, C, D. Now there is one more graph G1 and it has three vertices A, D, C. Now we say that G1 is subgraph of G if all the edges of this G1 and all the vertices of this G1 are there in G. So let us see whether A, D, C, whether these three vertices belong to G. Yes, they belong to G. Okay, and edges, say E1 and E2, whether these two edges exist in G. Yes, E1 and E2. Now we say this G1 as the subgraph of G. Is that clear? So all the vertices and edges of G1 are in G. Therefore we say that G1 is the subgraph of G. Now each edge of G1 should have same end vertices as that of in G. Okay. Here AD, this E1 edge has vertices A and D, whereas again in G also it has end vertices at A and D. So this is about subgraph. Now there are some things to remember about this subgraph. Every graph is a subgraph of itself. Say if I draw this as the graph, say there are two vertices A and B and there is edge E1. Now this graph is subgraph of itself. If I draw sub A, B and E1. Now what is the condition for subgraph? All the vertices of this G1 must be there in G. So there are two vertices A, B and both belong to G. And there is one edge E1 and it belongs to G. So every graph is a subgraph of itself. Now second point to remember about this subgraph is every simple graph of n vertices is a subgraph of complete graph Kn. If we have complete graph Kn, then you take any simple graph, it is subgraph of this Kn, because Kn is the graph which has, say for example, if there are four vertices, then there will be edge between every pair of vertex in this Kn. So this is complete. Therefore any simple graph is a subgraph of Kn or complete graph. Now one more result or one more point to remember about this is, if G1 is a subgraph of G2, say it is a subgraph of G2 and G2 is a subgraph of say G. Now G is a subgraph of, G1 is subgraph of G. Okay, it is like transitive property. G1 is subgraph of G2, G2 is subgraph of G, therefore G1 is subgraph of G. Now one more thing, a single edge in a graph G together with its end vertices is a subgraph of G. Now say in this graph, again I'm taking this example, single edge I will consider AB, but it has same vertices, say it has E3. Now E3 is, say let us assume it is G2. So G2 is a subgraph of G because it has single edge with same end vertices in G. Okay, and one more point, a single vertex in a graph is also a subgraph of G. Say in this graph again, in this example again, I'll take only one point B. This is our graph with a single vertex. There are no edges. It's fine, it is graph. Whether it is a subgraph of G, if it is a G3, whether G3 is a subgraph of G, yes it is, because this vertex belongs to G. Okay? Now next, we discuss about spanning subgraph. Now this, what is a spanning subgraph? Let us discuss. If there is a graph G, say with V and E as the set of vertices and set of edges, if there is a subgraph G1 with V1 and E1 as the vertex and edge sets. Then if there is one more G2 with V1 is equal to V2 means, so sorry, not this, V2 comma E2. Now we say that G1 is the, here in this example, G1 is the spanning subgraph of G because it has all the vertices of G. Say how many vertices are there in G? 4. A, B, C, D. All the vertices must be there in subgraph. This is the subgraph and there are all the vertices. We are not worrying or bothering about the edges. Whether all edges are present there or not, it doesn't matter. All the vertices should be present in subgraph. Then such a subgraph is called as spanning subgraph of G. Okay, but G2 is not spanning subgraph of G. Let us see whether it is subgraph of G. Yes, it is subgraph of G because all the vertices B, C, D, they belong to G and these edges belong to G. So this is no doubt subgraph of G. But whether it is a spanning subgraph of G? No, because there is no vertex A in this graph. This vertex is missing. So, so we say that G2 is not spanning subgraph of G.